Okay, welcome. So today we're going to be talking about ionic compounds. We're going to be learning how to name them, and we're going to be learning how to write out their chemical formula. This is probably going to be one of the first things that your teacher does in grade 10 in the chemistry unit. So we're going to go over it a bit now, and by the end of this video you should have the basics down. So what is an ionic compound? An ionic compound is formed when elements gain or lose electrons to become ions. Now, if you remember, ions are charged atoms. So an atom is protons and neutrons heavy in the nucleus with all these electrons orbiting around it. And those electrons can leave, and an atom can also gain more electrons. When an element gains or loses an electron, it becomes an ion. Now, positive ions and negative ions have different names. Positive ions are called cations, and these are usually metals, which we'll see. This has a lot to do with how the periodic table is laid out. But positive ions are usually metals. Negative ions are usually non-metals, and they are called anions. So the reason that these atoms are gaining and losing electrons is because they want to create a stable outer shell. Now, if you remember your Bohr-Rutherford diagrams from grade 9 science, you'll remember that each shell, well, pretty much each shell except for the first one, has 8 electrons. It has space for 8 electrons that it can fill. And it's most stable when that outermost shell is filled with 8 electrons. So if something has 1 electron in its outer shell, it's more likely to lose that electron than it is to gain 7 more. And this is called a stable octet. So octet just means a group of 8. The final thing to say about ionic compounds is that they're always formed between a metal and a non-metal. And we can see why that makes sense is because positive ions and negative ions will bond together because they're attracted to each other. Positive ions are attracted to negative ions. So the electrostatic force between these different ions is really what's going to be holding these ionic compounds together. And that's why they're always formed between a metal and a non-metal. So these tend to be solid at room temperature, and the example that I'm going to give you and the example that's used in this diagram here is salt. So good old table salt is really the classic ionic compound, and it's made up of sodium, which is Na, and it's a positive ion, and chlorine, which is a negative ion. And you can see here how there's this big crystal lattice. It's called a crystal lattice, but it's just a bunch of ions stacked up together, and you can see that it's a three-dimensional matrix. So we have like side to side, back and forth, up and down. So this is all a big cube here. And this is a big cube of different ions. And they're always repeating arrays of these ions, and they always happen in fixed ratios. And this is going to be important when we go to name them. But the fixed ratios are determined by each atom's valence electrons, or how many electrons exist in the outer energy shell. And remember, we're trying to get to 8. So the number of valence electrons is going to determine what charge it's going to have when it gets to that stable octet. So let's talk about how to name ionic compounds. This is the first thing that we're going to go over. So when you name ionic compounds, they're always named the same way. So there's always these 2 rules that we're going to use when we name ionic compound. So the first part of the name is always the name of the positive ion. So remember how we had Na+, and that was our sodium ion. This is always going to go first. The second part of the name is always the negative ion, which makes sense. The first part is positive, the second part's negative. But the difference here is that the second part, the negative ion, we always change the end of it. We always add "ide" to the end of it. So for example, chloride, you can see the IDE at the end here. So the first part stays the same, sodium stays sodium. And the second part, chlorine, becomes chloride. And you can see the "ide" here, which has been changed from the "ene." And the "ide" on the end just means that we know it's a negative ion. So sodium chloride means that they're bonded together in an ionic compound. Sodium chlorine would be, we don't know what that is. That doesn't really mean anything. But sodium chloride with the suffix "ide," the suffix just means end of the word. And that's really what's going to tell us that this is in fact an ionic compound. And this is actually the ionic compound. This is the chemical formula, or the chemical name for salt, sodium chloride. Okay, so let's practice a couple of these. So sodium, we know from the last one, the positive ion, it's a metal, sodium. And for fluorine, we're going to take this INE at the end and we're going to replace it with ide. So we're going to get FLUORIDE. I always spell fluorine wrong. So sodium fluoride. If magnesium and oxygen combine to make an ionic compound, well, we know that magnesium is a metal and it's going to be a positive ion, so it's going to go first. So magnesium. And oxygen is going to be the negative ion, and because it's the negative ion, we're going to replace the end with ide, IDE. So magnesium OXIDE, magnesium oxide. Calcium and bromine, same thing. Calcium is a metal, so it's going to be the positive ion, so calcium. And bromine here is in the same group on the periodic table as fluorine. And we're going to have this INE is going to change to an IDE. So this is going to become calcium bromide. And finally, strontium and sulfur. Strontium is a metal. It's in the first group of the periodic table. So strontium. It's a metal. It's going to be our positive ion. Sulfur is a non-metal. It's going to be our negative ion. And we're going to have to change the end of this, and we're going to have to add ide. So strontium sulfide. So you can see all of these names all end in IDE. So now that we know how to name them, we're going to learn how to write their chemical formulas. And this all comes down to determining that ratio that we talked about. So the ratio in that crystal lattice is what's going to allow us to write the chemical formulas for these different compounds. So to write the chemical formula of an ionic compound, we use the ratio, like I said, the ratio of ions needed to make a neutral charge. So when we say neutral charge, all we mean is that the total positive charge equals the total negative charge. So positive equals negative. So the neutral charge is when the positive equals the negative. So let's look at our example here, potassium bromide. So it's potassium and a bromine. Potassium is +1. So when you see a plus or a minus, it just means that it's 1. It just means that there's 1. You might see plus, 2 plus, or 3 plus, but just a plus means just 1. So we have 1 potassium, it's +1. Bromine is -1. So to be neutral, we need 1 potassium and 1 bromine. Therefore, the formula is going to be KBr. We're just going to put both chemical symbols next to each other. This could also be written as K1Br1, of course, because there's 1 potassium for every bromine. But we're not going to do that. We're just going to, by convention, say KBr, and we'll know that the 1s are in there just by convention. So next, let's look at magnesium chloride. So this is a little different because magnesium is +2. Magnesium is +2, but chlorine is only -1. So if we had 1 chlorine and 1 magnesium, it wouldn't be neutral. We need to have neutral charge. So in order to cancel out the 2 plus from the magnesium, we need 2 chlorine ions. That's going to give us a ratio of 1 to 2, and we're going to represent that by saying 1 magnesium to 2 chlorines. And that's how we're going to show it. We're going to say that there's 2 chlorines, and we're going to use a little subscript here. So we're going to write MgCl2. This little 2 means that there's 2 chlorines for every 1 magnesium. So let's look at a bit of a more complicated example here. Okay, so we have aluminum, which is +3, and sulfur, which is -2. We're going to learn how to find out what the charge is in a minute, so don't worry about that. You don't have to have it memorized. So in order to bond these two together, we need to make it neutral. But right now, we have 3 and +3 and -2. So the whole thing is +1 charged, and that's not going to work. And it turns out that to get to neutral charge, you need 2 aluminums and 3 sulfides. So the ratio is 2 to 3. And we're going to indicate that here, aluminum 2, sulfur 3. So it always refers back to the one before it. This little subscript always refers back to the one before it. So we're going to look at a bit more of a comprehensive way of how to do this in a second. What we're going to do is we're going to do something called the crossover method. And this is just a really easy way to write out the chemical formula of ionic compounds in a way that's simple and repeatable, in a way that you can always do it. So these are the three steps that we're going to take. So the first step is to write each ion beside each other. So we have magnesium and chlorine. But since an ion needs to have a charge, we need to find out what charge these will have. And we're going to find out what charge they'll have when they have that stable octet. The way we do that is we're going to go to our periodic table. And every periodic table should have in the box, so here's magnesium, and it should have a little charge here. And that charge is going to indicate what charge the ion will have with a stable outer electron shell. So magnesium is going to lose 2 electrons, so it's going to lose electrons, it's going to become more positive, and it's going to be positive 2. Okay, so let's write that down. 2 plus. For chlorine, we know that chlorine's over here, and we see that it's going to be negative 1. So for chlorine is negative 1. Okay, so now what we're going to do, now that we have our ions, we're going to take the amount of charge from the positive ion and use it as the subscript for the negative ion. So the amount of charge from the positive ion is this 2 plus, and we're going to use that as the subscript for the negative ion. So our negative ion is chlorine, and we're going to take this over here like this. We're going to put it there. So this is going to be 2. Now we're going to take the amount of charge from the negative ion, so that's our 1, and we're going to use this as a subscript for the positive ion. So this is going to come all the way over here. It's going to be a 1. And what we're going to get is MgCl2. So Mg, the 1 goes away, Cl2, 2 comes from the plus 2 of magnesium. We take that down, we put it below as the subscript of the chlorine, and that's going to give us our chemical formula. And just for fun, let's name this compound. We have magnesium is our metal, chlorine is our non-metal, it's our negative ion, but we have to add "ide" to the end. So we're going to get magnesium chloride, MgCl2. Okay, let's try some examples. So sodium and fluorine, the first step is to write down our ions. So we know that sodium here, symbol is Na, and the charge of the ion is +1. So let's write Na plus. Here it is here. Fluorine, its chemical symbol is F, and it has a charge of -1. -1. Okay, so now we're going to take the charge of the positive ion, use it as the subscript for the negative ion here, so it's going to be 1. We're going to take the charge of the negative ion and use it as the subscript of the positive ion, again 1. And what we're going to get is NaF. And just for fun, this is going to be sodium, and fluorine becomes fluoride, sodium fluoride, or NaF. Next, we're going to look at magnesium and oxygen. So magnesium, we know that magnesium here is always a +2 ion, and oxygen here is always a -2 ion. So let's go back to our sheet here. We'll write out the ions, our first step. Mg2 plus, oxygen 2 minus. We'll take the charge of the positive ion, use it as the subscript for the negative ion. Charge of the negative ion, use it as the subscript for the charge of the positive ion. We'll get Mg2O2. Now, if this was math class, would we leave it like this? We would not. So what we need to do is we need to divide both by 2, because this is basically saying that there's a ratio of 2 to 2. But this could equally be 3 to 3 or 4 to 4. The only way to make that clear is to take away these 2's. So MgO is what our final answer is going to be. And that's, of course, going to be magnesium oxide, MgO. Okay, let's look at calcium and bromine. So calcium, let's find it here. It's right under magnesium. So it also has a charge of +2. And bromine here, all the way over here, is also going to have a charge of -1. Now you can see here there's a bunch of other charges. These are like the polyvalent states of bromine. You don't have to worry about that. You just need to worry about this -1. And the way that the periodic table works is that each row, each column indicates an additional electron in the outer shell. So this here, these guys have 8 electrons in their outer shell. So this is full. They don't really bond with anything. These are called the noble gases. These guys have 7 electrons in their outer shell. So they're typically going to gain 1 and become -1. Here in group 6, these are going to gain 2 and become -2. These are typically going to gain 3. So 3 plus 5 is 8, that full shell. And just the same over here, these guys are usually going to lose 1. These guys are going to lose 2. So their charges are typically +1 and +2. But let's look at calcium and bromine. We'll go back to our example, Ca2 plus, Br -1. We'll take this 2 down and put it here. We'll take this 1 down and put it here. And we'll get CaBr2. So for every one ion of calcium, there's 2 ions of bromine. And this, of course, is called calcium bromide. Calcium bromide. Last example here, let's look at strontium and sulfur. So strontium is one you might not know where it is. Strontium happens to be right under calcium here. Because it's in group 2, it tends to lose 2 electrons and become positive. Sulfur here is right under oxygen. It tends to lose 2 electrons. So we have Sr2 plus, S2 minus. Take the +2, put it down here. The -2, put it as the subscript of the positive ion. We end up with Sr2, S2. These 2's are going to cancel out. SRS is our chemical formula, and it is called strontium sulfide. Okay, that's everything for this lesson. I hope that was a helpful overview of ionic compounds. We're going to be doing lots of practice with this stuff, and a lot of things are going to build on this. So make sure that you have a good, solid grasp of it. But if you follow the crossover method, you follow the sort of adding I to the end of the negative ion, you're going to do just fine. Thanks very much, everybody.